To build on the last few concepts, sometimes on the exam you'll be given an empirical formula, which, if you recall, is the simplest ratio of the atoms in a compound, and then the mass of the molecule, and that would be the mass of what the actual number of atoms of each element are, all added up together. So this is a really tough concept, but I'm going to try to illustrate this a little bit by looking at the same empirical formula, CH2, and then talking about what the different possible molecules could be using that empirical formula. You could double the subscripts on this formula and get C2H4. So what would happen to the mass if you did that? Well, if you're doubling the number of atoms, wouldn't you just be doubling the mass? What if instead of doubling it, you tripled it, making it C3H6? Wouldn't that just be tripling the mass as well? So the factor that you've actually multiplied through the subscripts is the same factor that you would multiply by the mass. So if you're given the molecular mass and you're given the empirical formula, from that you can figure out what factor was used in order to come up with this mass. So what we're going to do as our first step is we're going to figure out the empirical formula's mass. So we have one atom of carbon times its mass, which is 12.01. And then we have for the hydrogen, again in this empirical formula, we have 2, which is 2.02. We add those up and we get 14.03. So then the question is, this molecule that we don't know anything about just yet except for its molecular mass must have been multiplied by something. This mass must be multiplied by something to get this one, because the ratio of the atoms is still 1 to 2, carbon to hydrogen. So all I'm going to do now, my next step, and I'm going to do this on the next page, I'm going to take that 56.12 and I'm going to divide it by my 14.03. And when you do that, you are going to get a factor of 4. So my next step was to take the molecular mass and divide it by the empirical mass. And then we got our factor. So what's that factor tell us? Well, that factor is going to tell us what we need to multiply through these subscripts in order to, and I'm just going to put it like this, in order to get our molecular formula. So we're going to have C4H8 as our molecular formula. So our last step, we took the empirical formula and we multiplied it by our factor to get our actual molecular formula. So those are the 3 steps to figure this out. Let's do one more example. Second example, we have an empirical formula of CH2O. You might recognize that as a sugar. And molecular mass is given as 150.15. So whatever the mass of this is, some factor was multiplied by that mass to get this. So we're going to kind of work through this puzzle to figure it out. My first step, I'm going to figure out my empirical formula's mass. So for carbon, I have 1. Its mass is 12.01 for a total of 12.01. Hydrogen, I have 2. At 1.01, the total is 2.02. And oxygen, I have 1 at a mass of 16. And again, you can get all of these from the periodic table. And I'm just adding these up, and I get 30.03. So the mass of my empirical formula is 30.03. My next step is to take my molecular mass and divide it by the empirical formula's mass to get that factor. And what you get is 5. That factor, then, you take the empirical formula and multiply through the subscripts that factor, and you're going to get C5H10O5. And that is the the molecular formula from that empirical formula and molecular mass.